Hello, everyone. In this video, I'm going to just do a brief explanation about solving exponential and log equations using the method of changing form. So basically, change between exponential and log form is one of the simple ways of solving exponential and log equations. Let's do a few examples just to illustrate how that works. Just to review, for a basic equation, I say basic equation for exponential and log, I'll use y equals log base b of x. A log form and exponential form, since these are inverses, we say the same b or base to the power y is going to be equal to x. So if you recall, there's no math really done when you change forms. When you change between log and exponential form, we're really just moving numbers and variables around. So the b that I have in my exponential on the right is the same base from the log. The y and the x is the same as before. So we'll do that with an equation. We'll just change forms. So for example, if I have the equation, or if I say the question solve, and I'll have something to the effect of 3 to the power of 4x equals 7. Now, more complex and quite often applied log and exponential equations are usually more complex than this. You can solve them this way, but this is more of your basic log equations. So, for example, I have just I just have a single exponent. I don't have anything tremendously complex on either side of the equation. In other words, they're mirroring what you see in my general setup at the top. So I see solve there. To more to that point, there's nothing else on the left side here, since this is an exponential form. There's nothing else on the left side here that needs to be moved over. It's just the exponential by itself. When you have that, then we can change between log and exponential form. So in log form, this becomes, let me change my color here, log base 3 of 7 now equals the exponent, which is 4x. So I've done really haven't done any arithmetic, maybe it's a better way of phrasing it. It is math, but no real arithmetic or too many calculations. I've just moved things around. Log base 3 of 7 is 4x. Now I'll solve. I'll solve arithmetically, or algebraically, excuse me, by dividing by 4. And now I have x is equal to log base 3 of 7 over 4. And keep in mind, that's not 3 to the power 7, even though, yes, I know it looks like it. It's read as log base 3 of 7 divided by 4. Now, since I'm doing this as kind of a general abstract question, this is a fine answer. Obviously, there's a decimal equivalent to this. I'm not going to go over that because in formal mathematics, an exact answer like this is preferred over a decimal answer. Now, if it were an application question, if there's some context to this, then a decimal makes more sense. But for now, I'm just going to keep it like this. And just keep in mind that if, let's just say, for example, that 7 was a 6, or let's just say it's an 8 to make this easier, you would not reduce that with the 4. So this 7 and this 4 exist separately. They can't interact. In other words, you can't reduce one with the other. So it's a common mistake I see some of my students make, so just make sure you don't do that. For comparison, let's say I have something to the effect of, I'm going to say something like 2 to the x plus 1. And I'm going to say plus 3 equals, and let's just say, let's say 9. Now, the difference between this one is on the left side, I do have an exponential, but I have this 3 here, so I can't change form right now. I need at least that left side to be just a single exponential by itself. So the first thing I'm going to do is move this 3 by subtracting both sides by 3. Now I have 2 to the x plus 1 equals 6. Now I have my exponential all by itself on the left. And now I can change forms. Now I do not want to get, even though it looks like you might, I see some students will want to divide both sides by 2. You say, well, can't you divide that? In this case, no. Mainly because it's not 2 times x plus 1. If that was the case, you could more likely do that. When x plus 1 is in the exponent position, this whole thing on the left, this expression is actually a function, so we can't just take part of it out. Short answer is nope, you can't do anything with that 2 because it has that exponent there. So instead, we'll change forms. Now we have log base 2 of 6 equals x plus 1. And now, like before, I'm going to solve by subtracting 1 from each side. And note, I'm not going to make this a 5. This is now log base 2 of 6 minus 1, just like this. And to make it a little more clear, more distinct, because it can be a little confusing, I want to put this 6 in parentheses. Looks weird, yes, but this is the way you'd write that. It would be incorrect to say log base 2 of 5. It does not work that way. Much like with an exponent, log is a function unto itself. It's very much like if you had f of 2, for example, minus 1, we wouldn't make that f of 1. F of 2 is some number unto itself. You would just leave it as is. Let's try a couple more just to make sure we are see a few more examples to make sure we see all possibilities. For example, same thing, same question is going to be solve 7 to the 2x minus 3 equals 11. My exponent is all by itself on one side, so I will change from exponential to log form. So log base 7, again from 7 here, of 11 equals 2x minus 3. And same idea. Now log base 7 of 11 is a number unto itself, whatever it is. I'm not going to worry about the decimal. So I'm still going to solve for my variable by following my order of operations. So we're going to treat the log base 7 of 11 just like some number, as if it were like a 2. So if it was 2 equals 2x minus 3, you'd add 3 to both sides first and then divide by 2. So this is no different. I'm going to add 3 to both sides. And again, I'm not going to make that an 11. This is just log base 7 of 11 plus 3. Kind of cumbersome, yes, but this is how you'd write it. I'll still finish by dividing both sides by my 2. Of course, they'll cancel out on the left, or actually on the right. And I'm left with x, and I like to switch. I like to put my x on the left side. So if you're saying, well, you had x on the right, why is it over there? That's just a way of writing it. There's no right or wrong way there. It's just preference. So x is still x. Doesn't change the fact that it is log base 7 of 11 plus 3 all divided by 2. And it must be written like this. Make sure the whole expression, log base 7 of 11 plus 3, is written over 2. And for clarity, it might be advisable to put that in parentheses. Is it wrong if you don't? No. It's more just to make sure it's clear what you're trying to write. And let's do the other way. Now I've done several from exponential to log form. Let's go back to log form. So let's say, for example, we're still saying solve. So all the questions that I'm giving you here are under the instructions of solve. Those are the directions. Or solve the equation, solve the exponential, solve the logarithm, whatever. Means the same thing. Now I'm going to say, we'll start with a logarithm, log base 3 of x equals 4, for example. Very much like with the previous questions, my log is all by itself on one side. It's not, for example, I'm not saying 2 plus log of x, etc., in which case our first goal was to get rid of that 2. Nope, it's just log base 3 of x equals 4. So I'll go straight to change into exponential form. My base 3 raised to the power 4 equals x. Now here, there's nothing else to really do. Done. X is 81, 3 to the power 4. let's try something a little more complex. Let's say, for example, I'll say log base 6 of quantity 2x plus 1 equals 2. Once again, my log is by itself on one side. I'm going to go straight to changing to exponential form. Base 6 raised to the power 2, so it's always raised to whatever the log is equal to, equals whatever's inside the log, which in this case is 2x plus 1, the entire thing. Whatever is in those parentheses goes on the right side here. And now I can do this one arithmetically. So this is now 36 equals 2x plus 1. From here, I'll continue to solve for x, meaning I'll first get rid of my 1 by subtracting. I'm running out of room. Let me go over here. So I have 35 equals 2x. Finally, I'll divide both sides by 2. And again, I'm going to keep it in fraction form. Can't reduce it any further, so I'm going to leave it as 35 halves. And one thing that I haven't touched upon very briefly here again is natural log. So I'll say natural log of 3x, let's say equals 2. Now don't forget natural log, or ln as we all pretty much say, means that we assume the base here is e, even though it's not written. We always can assume that. So I have my log all by itself on one side, and it doesn't matter that it's natural log, it works the same way. So base e to the power 2 equals whatever's inside my parentheses, though, or whatever I'm taking the log of. 3x. Now, remember, e has a value, 2.71282, et cetera, et cetera. It's not important right now. We're looking for an exact answer. There's no context to this, so it's fine keeping it like this. I will solve, though, by dividing by 3. And it's just going to be that e squared over 3. And that's going to be my solution. And finally, just because I've mentioned it before, here's an example of when you can't start right from switching to exponential form. I'll say log base 4. Let's say of 3x equals, or excuse me, let's say plus 3 equals, let's say 10. Now I can't switch forms because the log is not by itself on one side. So the first thing I'll do is move this 3 by subtracting 3. So I can't have anything added, subtracted, or even multiplied by that log. Meaning that if I had, let's just say I had a 2 right there, my next step here would be to divide by 2 to both sides and then switch. But from here, now I have log all by itself on one side. I will change forms. Now I have 4 to the power 7 equals 3x. And that is a large number, 4 to the power 7. Other ones I've done, they were nice, cute little small numbers that you could easily do on even in your head. So we can, if you want, we can make this 16,384 equals 3x, which is not a pretty number, but we can divide and get 16,384 over 3 as a solution. Or if you prefer, you can just say 4 to the power 7 over 3, and that's an equally valid answer as well. That is more of a preference, or whatever your teacher tells you to do. So hopefully this helps in whatever math you're working with, and have a good day.